Next, we'll look at properties of option prices related to time, which is time to expiration. So American options are pretty easy. Whether they're puts or calls, American options must get more valuable when the term increases, because a longer-term American option has all the same optionality as a shorter-term American option, plus additional optionality. Well, additional optionality is valuable. So for American options, it's easy, namely that the greater the time, all else being equal, fix the strike price, it's on the same stock. American options are going to increase in value as the time to expiry goes up. How about Europeans? Well, European calls on non-dividend stocks are easy, because a European call on a non-dividend stock is, in fact, the same price as an American. So if we're dealing with non-dividend stock, European calls will also grow with the time to expiry. How about European calls on dividends paying stock? Let's think that through for a moment. Well, we already saw the problem with calls and dividend paying stock, and that is when dividends are paid, the price of the stock drops, and that makes exercise later less valuable than exercise now, because our right to buy at the fixed price is worth less. So we can see that it may not be the case that as you increase the term of a European call, it increases in value, simply because during the increased term, the stock pays a dividend and makes exercise worthless. So we have to be careful there. How about European puts? Well, again, European puts can be less valuable for the same reason, that you have a right to sell at time 1 year versus time 2 years. Is the right to sell at time 2 years more valuable than the right to sell at time 1 year? And the answer is no. One can think about cases of bankruptcy or whatever where the value of the stock is dropping to zero, and if I could exercise earlier, I could get that profit and invest it, whereas if I exercise later, I lose the interest on my invested profit. However, the book shows that if the strike price grows with the risk-free interest rate, then in fact European calls and puts on non-dividend stock will increase with time. These are not common in the marketplace, but it's an interesting observation. The next property of option prices we'll look at is properties related to the strike. Some of these are apparent, some perhaps not. So let's imagine we have two strike prices, K1 and K2, and let's say K2 is larger. So first of all, if we have calls, the call with the lower strike has to be more valuable than the call with the higher strike. Why? Well, this is the right to buy for K1 dollars versus the right to buy for K2 dollars. Again, everything else is the same. It has the same term, same stock. And what we're saying is having a lower strike price increases the value of a call. Having a higher strike price increases the value of a put. It's more valuable to have the option to sell a stock for $20 than it is to have the option to sell a stock for $10. So these relationships are apparent simply by the definition of put and call. Now, we know that the relationship with calls is that if K2 is bigger than K1, which is the call, how big can this be? We know that this call, the right to buy at K1 is more valuable than the right to buy at K2. So we know that this is bigger than or equal to 0. That's what we saw in the prior slide. But how big can it be? And the answer is it can't be any bigger than the difference in strike prices. If I have an option to buy a stock for $10 versus to buy a stock for $20, the difference in those values can't be more than the $10 difference in the strikes, because that's the most that will happen on exercise. One has the same relationship that in the prior slide we saw that the put at the higher strike is more valuable, so this is a non-negative number. But how big can it be? Again, the difference in these put prices can't be bigger than the difference in the strikes. One could imagine if they were, you could do a simple example where you have, let's say, a put at 10, a put at 20 minus a put at 10 is equal to $15. In other words, bigger than the $10 difference. And it would be an easy arbitrage that the put at 20 is way too expensive. And what would you do? We can see from this equation, this is a case where the difference in the put prices exceeds the difference in the strike. It would be an easy arbitrage. Apparently, the put price with a 20 strike is too high. So we would sell that put price, and we would buy the put at 10, and we would end up with a $5 profit. This is an easy exercise. So arbitrage enforces those relationships.